Alright, welcome to my KallumOS Showcase. To be clear, this is not a real operating system, but it's instead an app that mocks being an OS. My vision for this project is for a user to be able to use my app and feel as though they are using an operating system and achieve whatever they want without having to leave. Right now, the only library being used is raylib, which is only being used to draw to the screen. This will eventually be replaced by my own custom shaders, at which point the program will be entirely my own code. To see instructions for using the operating system, or instructions for developing apps for the OS, you can go to the GitHub page, where you can see all the instructions, and see the release logs. Okay, so let's get into it. To start, you want to create an account, so let's do that. Open up the app. So click create account, give it a username, a password, and validate the password. If there's an issue when creating it, the screen will go red, and if there is no issue, then the screen will go green. This sort of red and green feature will be updated soon to use text output, but this was the first feature that was made, so it's a bit lackluster. It's very primitive, but yeah, text will be added soon. Alright, so we've made an account, so let's log in. Hopefully you've not forgotten your login yet, we just made it. If there's a problem, again, screen will go red, and if it's not, then you'll be sent into the operating system. Okay, so now that you're in, you can see the extent of the OS. There are processes, and a taskbar that stores all the processes. Each process can have a window, so this is the app launcher, and it's visualizing all of its functionality inside of this window. Windows can be moved around by clicking somewhere on the grey part of this bar and moving your mouse. They can also be minimized and brought back by clicking on the task in the taskbar. Yes, right now I know there's no icon, so it's just a number per app. And apps can also be closed by clicking on the close button. If you close the app launcher, just make sure there's nothing focused on the taskbar and press the A key. That'll bring back the app launcher. And that's making sure there's nothing focused, not that the app launcher is not available. So right now there's nothing focused, we press it again, and now we have 2 instances of the app launcher. You can do it again and bring up 3. Okay. Alright, so this operating system has its own event system. Applications and controls like buttons and text boxes have access to the event system. Events are triggered when events like mouse move, key press and mouse clicks are detected, and they are passed through to each app, and then in the app you can choose, when you create the app, which controls, like buttons and text boxes, to pass each event down into. It's very similar to how events are handled in things like Unity or other more high-level languages, like C# and Java. Alright, so we've already seen the app launcher. It's the first app you're going to interact with. To open an app, you can scroll through the different apps that are available until you find one you like, and click on it to open it up. So for now, let's open the text editor. Okay, it's very basic, you can write text. To see how we can manipulate apps outside of an app, so instead of minimizing or closing the app from the app itself, if we want, we can open up the task manager, which shows a list of all the tasks. Each app does not necessarily have to go in the taskbar if it's a hidden app, and it does not necessarily have to have a visualization, again, if it's a hidden app. All the apps that are available in the default operating system is visual, so they all show up in the taskbar and have visualizations. However, if you want to end an app that you can't see, you can open up the task manager, find the app you want to close, so in this example it's the text editor, and click the close button. That destroys the app. As you can see, it's gone from the taskbar and it's no longer visible. Okay, so let's open up the text editor and we can see the file manager working. Let's write a piece of text, say test piece of text. Alright, so we'll save this amazing masterpiece. We'll give it a name, test.txt, and we'll save it. Alright, so let's say we accidentally close a text editor. You think, oh no, where did my work go? We open the text editor and it's not there. Not to worry, we did make a save. So we click the open button, brings up a similar dialog box, but this time we're selecting rather than saving. We select the file that we want, in this case test.txt, and we click select. And like magic, the text that we wanted is back. We can make an amend by adding some stuff, or we can just close it. Okay, so let's look at another app that we have. Any good operating system comes with entertainment. In this case, we've got the classic Tetris game. This shows the event system a lot more thoroughly. Each app has a tick where logic happens, in this case, moving objects about. The key presses, also part of the event system, allow the user to manipulate where the objects are. In this case, the Tetris pieces. And we have access to timing and drawing to the screen, which we've already seen. And I'll probably just speed this up. The objective is to get 20 lines cleared in as fast as you can, so I'll speed this part up. Okay, so we finished the game. I cleared 20 lines in 86 seconds, probably a world record, I think. If you want to restart and we're playing the game, but we're playing badly, alright, we only survived for 3 seconds and we had 20 lines left to clear. Cool. And we'll look at another app. This is the last one that I'm going to be showcasing. This is my programming language named Kode. It's very, very bare bones right now. It allows for variable creation and variable assignment and variable outputs. So if we just hit F5 with the default program, we will see 2 outputs to the console: hello world, hello second line. Each statement is ended by a semicolon, so when we hit a semicolon it creates a new statement, and statements are done in the order that they show up on your screen. So hit F5 again, and this time it's only outputting up to where we put the semicolon. To create a variable, right now integers are supported, so we say int, we'll give it a name, foo equals 5. Okay, we hit F5, nothing happened, but if we hit F3 for debug mode, we'll see we get to see the behind the scenes of what's going on in the program. Integer foo was created with value 5, so that's what we expect, and line3 is an empty statement. It's not really doing anything. Okay, so let's manipulate the variable that we just made. We'll say int, no, to manipulate we just give it the name and then equals, let's say, foo times 2. And we'll output it so we don't need to use the debug mode. Alright, so we created foo equals 5. Foo times 2 is 5 times 2, so that's 10. And we have 10. In this operating system, in this programming language, if an error is found, it doesn't crash the program, but instead it will skip that operation and continue. It will tell you in the debug mode that an operation was skipped, so potentially some sort of unexpected behavior could occur. So let's show that's happening. Let's do foo equals foo divided by 0. This is undefined behavior, so I'll try this out foo. Let's do F5. Yeah, here we go. So it's saying number 3. Okay, well, the numbering seems to be wrong, but the idea is try to divide by 0, division operation skipped. So 10 is what it was assigned to before the division was tried, so the division was skipped, so it's still going to be 10. So we can output variables. We can also if the output was not a valid function, so a variable, or I think if I do this, yeah, so output is expecting either a function, which is either a variable or some sort of variable assignment, or out 4 plus 6, some sort of functionality. The output will detect that, resolve the function, and output whatever the resolution was. And if it was not a valid function, so not valid function, it will just output that as a string. So yeah, the last one is not a valid function. Excellent. Okay. And I just want to add in, eventually I'll add if statements and while loops to this code programming language, which will require some refactoring, but it's in the progress. Okay, so we've gone over the main functionality of the operating system. New apps that are made will build off of the functionality you've seen, and it's pretty much just limited by whatever you can do in C++. This is basically a container for C++ programs with engine-like features like the event system, drawing to the screen, the ability to host apps that can be launched and closed, and a login system, and more features that are yet to come. As I'm working on them, I'm also implementing my own project management. So this is my linear site that has all the things I want to do, the things that I'm working on, and things that have been done. So yeah, that is my app. If you want to use it, you can access it from my GitHub page. You can clone it, build it, do whatever you want, although I don't imagine many people will use it. It's not very usable yet, but yeah, we'll see. Thanks for watching.